Hi, in this video, I will be showing you problem number 11 of chapter 13, section 4. Find the velocity, acceleration, and speed of a particle with a given position function. It's kind of similar to the problem that we discussed before, problem number 5. The problem there in 5, problem number 5 was two-dimensional and this is three-dimensional. That's the only difference. The method is the same though. So how do we find velocity, speed, and acceleration of a particle that moves along a space curve? If r of t is the position vector of the particle on the space curve, then the velocity vector v of t is given by r prime t. Then the speed is absolute value of the velocity or the length of the velocity vector. Then the acceleration is the derivative of the velocity vector, which is the second derivative of the position vector. So this is something basic that we all know from Calc 1 class. And the only thing is here we are doing multi-dimensional, several variables, and there it was only single variable. So first let's find out the velocity, which is r prime t, which is done by differentiating each component of the position function r of t given in the problem, which is root 2 I plus e to the t j minus e to the negative t k. So that is the velocity. Then the acceleration is the derivative of the velocity. So we are going to differentiate the previous step, number 1. So v prime t is the derivative of 2, which is 0. Derivative of e to the t is e to the t. Derivative of e to the negative t is negative e to the negative t. Substituting this, you get 0i plus e to the tj, minus of minus, that will become e to the negative tk with the positive sign in front. Now we have to get only the speed, which is the magnitude of the velocity vector. So if you look at the velocity vector here, it is number 1. So you have to square root 2, square e to the t, square e to the negative t, and add. So we get root 2 square plus e to the t square plus negative e to the negative t the whole square. If you simplify, it will become 2 plus e to the 2t plus e to the negative 2t, which looks like a perfect square inside. So it is e to the t plus e to the negative t, the whole square within the radical. So square and square root cancel out. You get e to the t plus e to the negative t, which is the speed of the particle. So this seems pretty straightforward. In the next video, I'll be showing a word problem involving force. And from the force, we will be evaluating what the position function is. Hope this video helps.